Hey friends, do you find it difficult to understand how this problem uses stack? Don't worry, I got it covered. So today we are solving the largest rectangle in histogram problem. So it states that there are some pipes are given with some height and their width is 1. We have to return the area by calculating the largest rectangle in them. So there are 3 rectangles. So this starts with the first index till the last. So the width is 6, height is 1. So the area is 6 here. Now in this problem, the same problem, there are the second rectangle. The height is 2, width is 4, so it gives us as 8, and the last one is this rectangle which gives us height as 10 because the width is 2 and the height is 5, so 2 into 5 is 10. So this becomes our max area. This is the problem we have to solve. Okay, what the pattern looks like. So take example only was this 2. So you see, if the current value is greater than the next value, we cannot extend this value any further. Okay, so what we'll do is we'll calculate the 2, where we'll calculate the 2 as the height, and then we'll get the area by using the width. Pole width is 1. But if you see, the 1 can be extended back also to the left side. Okay, so this is one thing. If we got pole that are bigger, so we are not computing their values, right? As we have popped this 2 value here, we computed it area because the current value was less than the next value. So 2 was greater than the next. Okay, the current value was greater than the next value, so we computed the value. But here the current value is not greater than the next value, so we'll keep on extending. Let me give you an example. Another example: 1, 2, 3 and 2 only. Okay, so if you see, we can extend 1, we can extend 2, we can keep continuing extending it because the next we don't know right now if it is greater or less, but as of now we know we can continue. But 3 we cannot continue. So what we'll do is we'll compute this value. Okay, we compute this value from where it starts to where it ends. So the width is 1. Okay, so we'll calculate the area. Conceptually wise, it will look something like this. Okay, we'll compute this value and we'll remove this value. So this is just conceptually. What if we have something that height is 1 only, like even? So we know that we cannot continue 3, so we computed this value. We know we cannot extend further, so we'll compute the value here, but we'll keep extending if the height is same or greater. Okay, so you see how the structure was something like this. Our structure was something like this. We started removing the element only if the value was the current value, like, and then we removed this value. So you see, it is like we are telling only execute the values that are most recent values. So 3 was most recent value, so we computed the current value. So it means that there can be something like stack where the most recent value is getting computed. I'm just writing C here. It means that it getting computed and we are popping this element. Okay, then we are popping the next most recent. So this tells us why this problem uses stack. So friends, let's look at the algorithm. So we have a stack variable where we'll store the height and index, and this is a max area variable where we'll store the max area. So at the start, we'll check if stack is empty or not. If stack is empty, then we'll just add the whatever the current value is. So we'll add here 0, 2, like index is 0. Now we are at 1, where we'll check if stack is empty. No, the stack is not empty. Then we'll say if current element is greater than whatever the top of the stack. If this is true, let me write it here. Current element is greater than whatever the top of the stack, then we'll add the value. But 1 is not greater than true. So what we'll do is we'll remove this 0, 2, we'll remove it and we'll compute it. So now the width is, it started from 0 and ended at 1. Width is 1, height is 2. So 1 into 2 is 2. So we got the max area. But there's one thing, like check it out. 2, even if we computed this, we have this 1 also that can be added here, right? So conceptually, after computing it, we'll be having something like this that starts from 0. We can say that this starts from the 0th location. The 1 height also starts from 0th location. So what we'll do is whenever any element that is getting removed, their index will add it to the whatever the next element is. So the value we are adding after computing, what we'll do is I'll say 0, 1. It means that the 1 starts from 0 also. Now we are at this position. We'll again say is current greater than the whatever the top of the stack. That is true. So we'll just add it. So 2, 5 I've added. Now is 6 greater than 5, that is also true. So we'll add the index, that is 3 comma 6. The index is 3, height is. But now the current value is 2. Is 2 greater than 6? No. We'll take out the value 3 comma 6. It starts with 3 and end at 4. We are at this current location right now, this 2. So it starts at 3 and end at 4. So we'll say 4 minus 3, that is 1, and the height is 6. So into 6. So the max area now becomes 6. And we pop this element, but the 5 is also greater than the current element, so we have to pop this also. So we'll pop 2 comma 5. The current index is 4, so that is 2 into the height, that is 5. It gets 10, so the max variable becomes as 10. Okay, and we have successfully popped this 2 element. Now the last element is smaller, so we'll not do anything. We can say that it starts at 2 also, because this is the last element which we have removed, and we can compute the 2 value from this height also. So what we'll do is we'll add the index for height 2, that is not 4, but index is this. Why? Because 2 is also here, so we'll say 2. Now the current index is this, so current height is 3, so I say is current height greater than whatever the top of the height in the stack, that is true. So we'll add the value, height as 3 and index as 5. Now we have value in the stack that is remaining. This is 5, index is 5, and I can say the height of or the length of this array is 6. So I'll again write a for loop. So this for loop is only to check if the values in the stack have max area or not. So I'll pop the first element. That is 5 comma 3. Index is 5. So our this length is 6. So 6 minus 5 into 3, the height. So it gives us 3. So no, this is we cannot update our max variable. Now these are 2 starts here. So 6 minus 2 into 2. So that is like 4 into 2 is 8. So this is also not the max variable. We popped out this value. We'll say 6 minus 0 and the height is 1. So that is 6. No, it is also not the greatest. So we'll return this 10. So this is how we are going to solve this question. So let's solve this problem. So first we have to take a for loop, and I is equal to 0, I is less than, height not length, I plus plus. Okay, in this for loop we have to create a stack and let a max area variable will initialize it to 0. So first what statement we wrote is if our stack dot length is empty. If it is empty, then what we are going to do is we were going to push into the stack first element. But the way we are pushing is the index. Okay, that index is equal to I. Now why I am doing it this, let me explain you. So if you guys remember this 2 1 where we computed this value, but we can start the 1 from here and we can compute, like we can get the area from this value also, the 1. So by rather like pushing into stack as 1 comma 1, this 1 is index and 1 the value, we can say that we can start from the 0 comma 1 in our stack. So that's why we are doing this. We're pushing it index in the current height, its heights. Okay, now if we have some value, what we said is if heights of, like if current value is greater than previous value, then we were adding them. As we are writing this check opposite, earlier we wrote like this: if current value is greater than the whatever the top value in the stack, we'll add them. We'll just reverse this condition. If current value is less than whatever the value is in the top of the stack dot length minus 1 and the first element. Why the first element? Because 0 is the index and the first is the height. If current height is less than the whatever the height in the stack, top height in the stack, so we'll pop that value. So we'll say underscore index comma underscore height is equal to stack dot pop. We pop the value. Okay, now we'll say const width is equal to current width, so that is I minus width of that popped value will give us width, and area is equal to width into this height which we had got. Now we'll say max area is equal to, okay, let's put max area comma area, and we'll update the index to underscore index. This is the important step to calculate this part where we are doing this, like we want to add this. Okay, what we'll do is we'll write a function only directly. We'll say const get value is equal to, this function will return stack and max area, and it will take height as a variable. So we'll say no, we'll not say const. I'll tell you the reason. Max, because the stack is not empty, and if stack is not empty, then we want to update the max, and if we say const, then this will give us error. We'll pass the heights. Now the thing is that like this stack has some value, like what if the values are something like 1 2 3 4, they all are incrementing, so we'll add into the stack. So that's why we'll check one for loop or while loop also in the stack. Is stack dot length const the array underscore index underscore height is equal to stack dot pop. Now to calculate width is easy, because we know the width of the complete array. Heights dot length minus the index at the position the value is, and we'll say area is equal to width into height. Okay, yes. Now we'll say max area is equal to max dot max of max area comma area. Will return the max area. Okay, so the time complexity for this is O of n, and as we are creating a space, so the space complexity will be O of n only. But just let's run this program. Okay, it got accepted. Let's submit. Okay, it got submitted also. So the time complexity and the space complexity is big O of n, because here also we are doing O of n. This will have time and space complexity of O. So friends, if you like this video, please do like, share and subscribe. Thank you for watching.